SOx in a partial burn FCC unit is not as straightforward as in a full burn unit. FCC additives tend to be less effective in partial burn units, and therefore costly hardware solutions are often required. In full burn units, there is no limit to the amount of SOx that can be removed. Typical SOx removal rates are in excess of 80%, with some units maintaining over 95% SOx removal. In partial burn FCCs, this is a different story. In partial burn units, SOx reduction is a function of oxygen availability. At a high percentage of CO, much of the coke sulfur burns to H2S and COS, which survives to exit with the flue gas and is converted to SOx in the CO boiler. SOx reduction additives only pick up SO3, so as the percentage of CO increases, the SOx pickup potential decreases. Special optimization of the oxidizing function is required to maximize SO3 formation in the regenerator without upsetting the CO to CO2 ratio. It is important to use a SOx additive designed specifically for use in partial burn FCCs. Use of a standard full burn SOx additive in a partial burn unit would result in indiscriminate oxidation, which is unintended oxidation of CO to CO2, which would upset the CO to CO2 ratio and ultimately increase CRC. SO3 is the only SOx species that an additive can absorb. Since less oxygen is available for SO2 to SO3 oxidation, an additive that contains oxygen complexes to assist in the formation of SO3 is required. In recent years, huge strides have been made in regards to partial burn chemistry. Insight has been gained into coke combustion under substoichiometric oxygen conditions and its effect on contaminant nitrogen and sulfur species. Johnson Matthey offers low SOx PVXL, a partial burn SOx additive that requires less than half the addition rate of previous partial burn SOx additives, and it has a specialized oxidation package to promote the SO2 to SO3 reaction with minimal effect on the CO to CO2 ratio. Commercial applications have proven low SOx PVXL's ability to reduce SOx by upwards of 50% in a partial burn FCC.